Good day, guys. Now let's take another example under performance specification for this thing, frequency domain. The question says the specification of a second order unity feedback control system with closed loop transfer function that are that the maximum overshoot must not exceed 30%, and they asking us to find the corresponding value of resonance, peak resonance, and bandwidth. Okay. Now in this question, just be aware that only what they provided for us is just what we call maximum overshoot or peak overshoot. So before we start solving, I want to make one thing clear. Now, what was given to us was for closed loop transfer function for a second order. This is the expression for it. For open loop, for the same second order, this is the expression for it. So they are not the same. Don't get confused. They're not the same thing. And in the last video, I also tried to explain how this came to be using the popular closed loop formula. You can follow from this, which is G over 1 plus GH, where H here is equal to 1. Right? So you can just say it's equal to G like this. So this is the formula they used to get this. They used solving taking this to be G. They used it to get this. So these two things are not the same. One is for open loop, one is for closed loop. So know the one you are being given before you start substituting to get your value. But in this case, they only just gave us the expression. They didn't give us the value of either damping ratio or natural frequency. They didn't give us the value for any of them. The only value that they gave us was only that of what? Maximum overshoot. So let us start solving. The first thing we are going to do is to write down the formula for our what? Maximum overshoot, presented as what? MP. Now this is equal to your exponential in brackets, that's the power, minus pi multiplied by zeta over the square root of 1 minus zeta square. So this is the expression for your what? Your maximum overshoot. So our aim now is to get zeta from here, because we're going to use that same value that we got to get for our MR, which we know is 1 over 2 zeta times 1 minus zeta square. Then that of our bandwidth, we also need for our bandwidth, we need WN. We need to know what WN is. 2. So at least let's start somewhere. From this, we can first of all solve our zeta. But as you can see, we weren't given WN, so we don't know what our undamped frequency is. So we'll just work with what we know for now. The main aim here is to get our zeta. Now, how we are giving what? Maximum overshoot to be what? 30%. MP is what? 30%. This is also equivalent to what? 0.3. Right? Now, we are going to use this to put it into this formula to get what our zeta is. Then that value, we get it and substitute it into this to get our final answer. Now, okay, it's going to be a long one, but it's mostly making our aim now just to make zeta and sort of formula. That's what this thing is all about. There is no technical thinking that is here. Just making this sort of formula. Now, let's get rid of this exponential. We find the natural log of both sides. We have in MP is equal to minus pi zeta 1 minus zeta square. Now we have gotten this. Okay, now from here let's cross multiply, and we have that in brackets the square root of 1 minus zeta square natural log mp is equal to minus what? Pi zeta, right? Okay, now let's get rid of this square root sign. So let's square both sides. When we do that, we have in bracket 1 minus zeta square natural log of our mp what square is equal to pi square zeta square. Opening the bracket, you're going to be having natural log of mp square minus zeta square natural log mp square is equal to what? Pi square zeta square. Now this is where our aim is, zeta. So let us take it over to the other side and make it a set of formula. So we will have that natural log of mp square is equal to pi square zeta square plus zeta square natural log mp square. Now zeta is here, we can now factor out, and we have pi square plus natural log mp square is equal to natural log mp square. Now from here we can then have dividing both sides by this, so we then have that zeta square is equal to natural log of mp square over pi square plus 1 and natural log mp square. Okay, now finally I guess okay, before we do that, you can actually leave it like this if you want. I won't penalize you, or still you factor out your natural log out, so it will have it in this form. That's natural log on top mp square over natural log mp square is now multiplying pi square over natural log mp square plus 1. So that when this guy multiplies this one will cancel out. We are left with this. When he multiplies this one, we get this back. So that these two can then what? Cancel out themselves. Then we then have that our zeta square is what? 1 over pi square over natural log mp square plus what? 1 plus 1. Now finally you can then find the square root of both sides. So we then have that zeta, after finding the square root, is now going to be the square root of 1, or the square root of 1 is still 1. So we can just say 1 over the square root of pi square over natural log mp square plus what? 1. So this is what we're going to be using to solve for to get our zeta. Now, substituting z, we then have that 1 over root of pi square over natural log, what is our mp? 0.3 square plus what? 1. So using this, we can get our zeta. So I got my final answer to be 0.358. So this is the value of my what? Damping ratio. The value of my damping ratio. Now, another thing they say we should look for is the main thing they say we should look for is what? Resonance frequency. What we just got now is just what? Zeta. Now we still need to now substitute this zeta value into our peak resonance to get our answer. So MR is equal to 1 over 2 zeta square root of 1 minus zeta square. Now substituting our values, we have 2 times 0.358 close bracket, then the square root of 1 minus 0.358 all squared. Microbiology. What am I doing? Okay. Okay. Okay, so we got our answer to be what? 1.496. So this is the answer of our what? Mr. That's peak resonance. Now they also demanded that we also get our what? Our bandwidth. Okay. Now the issue with this is that our bandwidth requires us to know what our Wn is, but that wasn't given to us. That wasn't given to us. So what we're going to do, we're going to be expressing it in terms of what? Wn. Okay, so I'll explain myself. Now we know that our bandwidth is equal to Wn multiplying 1 minus 2 zeta square plus the square root of 4 zeta cube. This is not cube, it's raised to power 4 minus 4 zeta raised to power 2 plus 2 z. Okay, close brackets. Now raised to power what? Half. This half means what? Square root. So it's either you put this raised to power half or you square root everything inside these brackets. They will still give you the same thing. So our Wn wasn't given to us. So but we can solve for everything inside this bracket, and we then write it in terms of our what? Wn. So whatever our Wn is, we don't know. So our BW, our bandwidth, is going to be expressed in terms of our Wn. So solving for this ones that we know, this one side the bracket. So calculator, you press from here to here. That's only what we're interested in, from here to here only. So substituting our value, we have that Wn is 1 minus 2 times 0.358 square plus the square root of 4 times 0.358 raised to power what? 4 minus 4 times 0.358 raised to power 2 plus what? 2. Okay. So now substituting substituted, now it's time for us to now get our answer. Okay, so we have that our bandwidth will be WA into what? 1.41 approximately. So we can then say that our bandwidth is what? 1.41 omega watts L. So this is our answer, and we're going to be leaving it at this. Okay, so that's all for this video. Like, share, subscribe, comment, and share with your friends, and keep being the best version of yourself. See you guys in the next video. Goodbye.